Welcome once more to Agam's lecture series, a lecture series designed to bring learning to the comfort of your home. We are continuing part 3 of our lecture series on STB 112, Morphology and Physiology. We have done the tissues, we have done the organs. We are today looking at the organ systems. And the first organ system we are going to consider is the digestive system. Remember, we have 8 other systems apart from the digestive: the reproductive, the skeletal, the muscular, the excretory, the circulatory, the respiratory, the nervous, and endocrine system. But we are going to start with the digestive system. The digestive tract of animals. Digestive tract of animals is of two. There are some animals that have complete digestive system or complete digestive tract. They include the annelida, the arthropoda, and the chordata. There are animals that do not have complete digestive system. This will include the protozoa, the hydra, the coelentrates, the platyhelminthes, the porifera, etc. Now, we are going to concentrate this our discussion on the mammals. So we are going to look at the digestive tract of the mammals. Digestive tract of the mammals. Digestive tract of the mammals. And why mammals? Because we human beings are mammals. That's why we are starting with the one that concerns us. Now, digestion in mammals has 5 stages. Digestion in mammals is broken into what? 5 stages. Namely, ingestion, digestion, absorption, assimilation, and egestion. We are going to tell this story because in biology we still tell a telling story. We are going to tell this story by taking this stage one by one. The first stage, which I will mention and tell the story about, is ingestion. Ingestion. What is ingestion? The act of putting food into the mouth of an animal is ingestion. Whether that animal is small or big, any process, any structure, the act of putting that food in the mouth of an animal is just ingestion. As it concerns us, the mammals, when you ingest food into our mouth, you know there's teeth in our mouth. You know there's tongue in our mouth. What does our teeth do in our mouth? What our teeth do is to break the food into small pieces, physical breaking. As it's breaking it, saliva is secreted by salivary gland in our mouth, and the food is mixed in our mouth. And the tongue, the tasting organ, we roll the food into small balls called what? Bolus, and move them down into the gullet. And move them down into the what? Gullet. Move them down into the what? Gullet. Muscles of the gullet contract to push this food down in a rhythmic contraction called peristalsis. Peristalsis. The muscles of the gullet contract to push this food down in a movement called what? Peristalsis. When you vomit, the contraction will go in the opposite direction, and you call it what? Anti-peristalsis. Anti-peristalsis. Now, when the food gets to the junction between the gullet and the stomach, note that in the mouth, the saliva secretes an enzyme called ptyalin. Ptyalin. The saliva secretes an enzyme called what? Ptyalin. This ptyalin acts on sugar and any carbohydrate to convert it to what? To start converting to maltose. The pH of the mouth is alkaline. The pH of the mouth is what? Alkaline. Alkaline. That is basic, alkaline. pH is alkaline. pH. That means the pH is greater than what? 7. Because 7 is neutral. The pH is what? Alkaline. When this food enters, the junction between the gullet and the stomach is controlled by the cardiac sphincter muscle. Cardiac sphincter muscle. When the food enters into the stomach, it is only carbohydrates that are digested in the mouth. Protein and fats are not digested at all in the mouth. When the food enters into the stomach, the presence of the food in the stomach will cause the walls of the stomach to secrete gastric juice. And the pH of the stomach is 2, which means that the stomach is what? Acidic. Gastric juice. Gastric juice, which is acidic. 2 enzymes are contained in this gastric juice. The enzyme pepsin and the enzyme renin. Pepsin acts on proteins to convert them to peptones, when renin acts on soluble milk to convert it to what? Insoluble milk. So renin is found more in small children. Pepsin and renin. Pepsin and what? Renin. These are the 2 enzymes in the stomach. But they only act on what? Proteins. They don't act on carbohydrate. They don't act on fats. Only on what? Proteins. Why this one convert protein to peptones? Renin convert soluble milk to insoluble milk. The bolus from the mouth is now becoming a little creamy, and it's called chyme. Chyme. Then the muscle between the stomach and the duodenum. The duodenum is the first portion of the small intestine. The muscle between the stomach and the duodenum is called pyloric sphincter muscle. Pyloric sphincter muscle. It relaxes more to open into the what? The first portion of the small intestine. And that first portion of the small intestine is called what? Duodenum. 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 Is U-shaped. Is U-shaped. In this duodenum, the pH there is alkaline again. Now changing from acidic to what? Alkaline again. This duodenum, the gallbladder will secrete gall. It will secrete bile into the what? Duodenum. Bile emulsifies fats. Bile emulsifies fat. The pancreas will secrete pancreatic juice into the duodenum. The pancreas will secrete pancreatic juice into the duodenum. The pancreatic juice will contain protease, enzymes that act on what? Proteins. Then what this bile does is to emulsify what? Fats. Then the duodenum, the pancreas also secrete maltase. Maltase is enzyme that act on what? Maltose, on carbohydrates. These 2 enzymes, this one emulsifies fats, protease acts on peptones, maltase acts on maltose sugar. They start working, the 3 parts of food, carbohydrates, proteins, and fats, are all worked upon in the what? Duodenum. After the digestion in the duodenum, the food is moved to the small intestine. The small intestine is called what? Ileum. Ileum is the technical biology word. Otherwise, you call it what? Small intestine. In the small intestine, the succus entericus of the small intestine will produce other juice. Succus entericus. Succus entericus will produce intestinal juice containing trypsin, amylase, and lipase. The trypsin acts on any available peptones and peptides and convert to the amino acid. The amylase acts on any maltose sugar and converts it to what? Glucose. While the lipase acts on any fatty acid to convert to fatty acid and what? Glycerol. Out of any fats and oil to come to fatty acid and what? Glycerol. Therefore, completion of digestion occurs in the small intestine. And then what is digestion? Remember that we are not just discussing the second stage of this. What is digestion? The breaking down of big food molecules into simpler forms, rendering them soluble and absorbable. Digestion. The breaking down of large food molecules into simpler forms, rendering them what? Soluble and what? Absorbable. Once digestion has finished the small intestine, digestion is completed. Now it is for absorption to take place. What is absorption? Incorporation of the digested food into the cells of the body. Taking up of the digested food into the blood stream, and from there to the cells of the body. Now, the small intestine are lined by finger-like projections. So, small intestine are lined by finger-like projections, like this, called finger-like projections, like this. These finger-like projections are called villi. Plural is villus. Their job is to slow down the movement of the digested food so that absorption can take place. Because if they run fast, the intestine will not be able to absorb before they go. So they create surface area for absorption to take place. And absorption is not the incorporation of the digested food into the body system. Proteins, end product is what? Amino acid. Carbohydrates, glucose. Fats and oil, fatty acid and what? Glycerol. These will be absorbed. While the amino acid will enter the bloodstream, the fats will enter the lymphatic vessel, where from there they go to the adipose tissues where fats are stored. And you know, it's this fat that make us fat or obese or thin, as the case may be, as earlier described. Now, when the food that enters into is absorbed, when the food is not absorbed, the next stage is what? Assimilation. Assimilation is the utilization of the absorbed food. Utilization. How is the food utilized? The food is utilized by the amino acids going to the liver for deamination, because liver is an important organ in the body. The fats and oil will be stored in the adipose tissue, while the glucose will go into the cells of the body where they are used for tissue respiration to release what? Energy. Remember that carbohydrates are energy giving foods. And when these assimilation are taking place, the part of the food that was not assimilated will continue and go through the rectum where they are stored temporarily, until when nature calls, they pass out through the what? Anus. Those phases you pass out through the anus was never absorbed in the digestive system. So that's why you don't call them excretory products. You call them what? Fecal matter. But those that are assimilated, if the glucose is broken down, water and carbon dioxide is released. Those water and carbon becomes excretory product because they've reacted in the cells of the body and we are giving out. Sweat is also an excretory product. And all the non-absorbed food will enter into the rectum. When nature calls, you pass them out through the anus. The passing out of rejected food material through the anus is what we call what? Digestion. In our next lecture, we look at other systems, the functions of the liver as a major organ, diseases of the liver, and then we'll take all the other systems one by one, especially the ones that is going to give you more challenges. Thank you for listening. And if you enjoyed this lecture, as we say always, click on the red button and you are good to have better days ahead. Thank you and God bless you.